All right, so I think this demo should work. So a little bit of a story. We were doing some testing the other day, and as part of the testing, we have a user story where a user uploads a Docker file into essentially what is an app, Azure App Service, and the app service hosts a Docker file, and it allows the user to access their data. It's like a dashboard. It's very simple dashboarding app. And when I was going through it, I this is when I had learned about this Dash app, so I kind of became very interested in it. Regardless of the test, like the test failed for me, but I was still very curious at it. But so when I look at that specific Dash app, it's a Python app. Let me just actually I'll just use the editor. So I'll just press period, open up the web editor, and make it a little bit easier for us. I'll just wait for this to load up. So come on, it's a Dash app. It's nothing super amazing to it. That opens up like on when the page renders, it's a plotty graph with a search, an add, and a delete um, forms or text boxes, so that a user can show their data, update their data, and delete their data. And it's essentially meant to connect to a Postgres database. Now, like in the Postgres database, like there isn't a ton of data that's in there. Like maybe, I don't know, let's say a dozen rows of data in a single table. And I was looking at the deployment for it, and it was like, all right, so what they're doing is they're taking this Dash app, building a container out of it, and then hosting the container, and then mounting that container in app service. So like the app service takes the Docker Compose, kicks it into Azure App Service, or Azure App Service mounts this Docker Compose, mounts the Docker image, because it's posted or published, it's publicly accessible, and the Postgres database already exists in um, in the Azure environment, and you can specify the database connection information via like environment variables that will get passed into the Docker file. And that's great. So, like right now, this application is a web server, a Python web server hosting a Dash app, and there's a Postgres database. And I was thinking about it, and it was like, why why use um, a Docker Compose file to host a single app? He was like how could you, like, what's what's the plus one on this one? And I started playing around with this. And if I go into my own project here, sorry, try not to breathe into the mic, and I look at this file, this is me playing around essentially with the same code base. And we'll just wait for this to queue up. And what I'm doing here is hosting. So, like, the Compose is spinning up a database with an SQL data dump that I captured from the database. Like for instance, like if we look at the, actually this path has changed. Don't worry about the paths being different. We look at the data. There's essentially one table with nine rows of data. Like it's a very simple, um, kind of like a demo app. All right. So just to jump back in here, so I'm telling Docker Compose, let's spin up a Postgres database. Go in Docker Hub and grab the latest Postgres database. Take my SQL file, like mount it as a volume, or yeah, mount the file as a volume, and then feed it into the SQL file. The Postgres um, the Postgres container knows to initialize this data when it's behind that path. So it'll prep the database, it'll stand it up, and then once it's ready, it'll spin up the web database. So it depends on DB. And in here, instead of me publishing my Docker image to Docker Hub or something like that, like I'll just do it on the fly. And if I look at that Docker file, where did it go? Here it is, Docker file. Like, so like, again, like that the +1 on this one is I'm taking what we had from the original project and I'm putting it into a hardened image. So using ChainGuard images, like their dev environment, we're building out the Python library requirements in a container. So that's the first stage. It's basically what it's doing here. It's creating the environment and installing the requirements. And then the second stage, it's instead of using the dev environment, it's using the Python, essentially like the run or like a running environment, which is a stripped down Wolfie image. I think latest dev is also Wolfie image, but it has the dev tools, including a shell, so that you can do some more work in it. Anyways, so in here, we're taking our production, let's call it our production environment, copying our Python environment that we built in our base image, setting the path variables, copying in that our dash app, so it's actually going into the container, exposing. We're setting the user to non-root. We're making a health check so that our services can watch it, and we're launching it. So like that endpoint's the same there in app.by. And if we're going over here, there. So like it's like we're taking it from like this kind of scratch base of a Docker file into like something that you could put online, and not online, but not, well, you could put it online, but the whole point of this is that there aren't any OS level vulnerabilities baked into the image creation. Like the CVE hit on this image should be 0. I haven't scanned it recently, but the last time I did scan it, it was 0. But anyways, this works. So like if I do it locally, if I do Docker compose up and then with the build tags, it'll build this image, spin it up, and then I can view that Docker image. And I would in this space, but I don't have a Linux terminal to do this in right now. This is just the web editor. But so it was doing it. Everything was working. And I took my Docker compose file and I put it into app service, and app service, like, it didn't like it. It didn't like it because of how I was doing the paths. It didn't like how I was doing the mounted volumes path. It didn't like it because I'm bringing files with me. So not only is it the Docker compose file, but you need the Docker file, you need the app.py, you need the data.sql. Like, there's a lot of stuff that has to come with it. And the thing that I'm trying to avoid is creating a Docker file that has data in it, just for this pattern. It just like, it didn't quite make sense to me that like this is going to live publicly, everything's public facing, it's very little data, you don't necessarily have to what was I going to say, there's no reason you can't just post this data in a consumable form online. And I was mucking around with this, trying to get it to work. So like you can set context in the build, so I can put, you can set context for your build environment, so I can tell Docker compose, like, this is where that file exists under that Docker file. Apparently that works. I haven't tried it, but like it still wasn't there because that Docker file needs to copy the app.py. Like it didn't work. The other challenge was in Azure. Azure wants to see this variable set. If you're going to mount volumes, it'll expose the app service instance volume to the Docker compose file, but you still need a way to get that file into data SQL. I mean, get that file into the Azure App Service, and just because of how our FSDH system set up, like that's not possible. So I was hitting all these roadblocks, and I was kind of trying to figure out like why am I mucking around with the database? He's like, this is like a JSON's worth of like a JSON object's worth of uh, data, or a text file. Like why is this why is this so expensive? And like in Azure, if you stand up a Postgres database, standalone Postgres database, like that's probably, I don't know, let's say it's $30. That seems too much. Let's say it's like $15 um, a month for that Postgres, like that basic Postgres database. Actually, I'll check the how much this costs after the fact, or at the end of this presentation. Let's say it's $15 to run a Postgres database, and that app service, like it's probably also let's say another $15 per month to run that app. So right there, we're at like $30 a month to run a simple Postgres database and a simple app service. And I was like, all right, so let's get rid of the Postgres. Let's get rid of the managed Azure Postgres database. Like it's not needed. And you can just spin one up in Docker Compose. Like I don't have to worry about persistent data. Like this data is cooked. Like it's not going to be changing anytime soon. And I was like, all right, well, we'll just bundle everything together with Docker Compose, and then we're only paying for the app service. So we've gone from $30 to $15, and I was like, that's kind of cool. I couldn't get that part to work, and I was like, all right, well, what other options are there? Because I know you can do like a JSON object, a CSV file, like what scales well, SQLite, SQLite. Um, these are all options, and I was thinking about it, and just doing some googling, and sorry, let me just open up the page here. I stumbled along this page. So this guy's talking about how do you hosting SQL databases on GitHub Pages. So GitHub Pages are essentially free hosting, and it's from 20 he wrote this in like April of 2021. And I was reading it, and it was like, it's pretty cool, blah, blah, blah. Like, it was all fantastic. And I got to the very bottom, and he's updated his work. And it was this part that caught my eye. So, like, I've always kind of used SQLite. How have I used it? In the backend. So you, like, bring in the library, mount the app.db file, and you basically just swap out Postgres for SQLite, and SQLite points to a file that's locally available to the web server, and everything just essentially works. But I was looking at the support for what's it called? Looking at the support for WASM, and when I was on the SQLite WASM site, it talks about SQL.js, and I was like, this is pretty cool. SQL.js. So yeah, it's a JavaScript library. So on the client side, you can use this library to stand up like a WASM, so WebAssembly. Is it WebAssembly machine or Yeah, it's WebAssembly. I'm not too sure what M stands for. Is that just? Yeah, it's just WebAssembly. All right, never mind. So it stands up this virtual machine. It's a virtual machine, a containerized virtual machine in the browser session that's now running that the SQLite database engine in the client's browser, in the client space. And it's like, oh, that's pretty cool. So all that to say, I am not the world's greatest. I am not the world's greatest programmer in terms of JavaScript or Python/Dash apps. And I've never used Plotly before. So I was using ChatGPT to help me do this conversion. But I asked ChatGPT to convert a file for me. And surprisingly enough, it did. So if I just jump back here, is this the right? No, it's the wrong one. Here we go. So if I just jump back here, so like there are online services where you can convert PostgreSQL dumps to like SQLite database files. So that's what I did here. I just took that file, converted it to that file. It's very, very easy to do. And ChatGPT helped me write this JavaScript file or this HTML file. So this is just a static page, just a static page loading up JavaScript that will load up the SQLite WASM and then load my data and then display it in a form. Like this is not a ton of lines of code. Like this app was never big. If there's anything worth mentioning here. So this is where it actually loads the WASM virtual machine. It's managed. And then you basically create functions to like query, add, and delete values from that database. So like that's the database. Here are the commands, the JavaScript commands to do the lookups. And then the visualization manager is the class to update the body. And here's Plotly. So this is how we create the Plotly instance. So originally Dash was using the DCC library. This is calling Plotly directly right here. So again, all in the client space. There's no backend. And this is where the WASM, the SQLite WASM file is loading up the database. So I'm hosting it on, for the sake of this demo, hosting it on GitHub. And it'll load it and it'll do the build. And so what does that look like? So let me just open up the other browser here. And if I let me refresh this page here for a second. So actually, let me just close this for right now. So this is the app. So you can just it looks up planets and it gives you a little bit of information about planets. So we like Venus, query database. So body type planet, mean radius of the planet, mass of the kilograms, and mass by kilogram, and distance of the sun. So that's it. This is just a Plotly graph. It's helps someone it's called add data. You can add planets. So you'd be like cheese, maybe radius of like 5. Again, we're just making stuff up here. We're gonna go add. So that should have added celestial body added successfully. That should have added Bob to the database that's sitting in the browser. There's Bob, cheese, yada yada. Okay, it's updated the Plotly as well. So yeah, that's it. Like there's a database running in the browser space of this session, and I was like, can I actually see the database or the WASM? And it's right there. So like it's sitting in the memory space of the browser session, and this is a database, an SQLite database engine running in the background of this browser, supporting all the queries that a normal database would. And I thought that was pretty cool, and I just wanted to show that. So I guess like the final summary here is we went from a place where you have a hosted Postgres database and a hosted web app, like Python web app, and kind of showing all the steps to get here in the evolution, and like kind of like trying to like remove, I don't know if it's evolution, but trying to remove all the wrinkles in that journey of like what's the leanest I can run this dashboard on, and it's to the point where now it's two static files. One's this HTML page, or it's basically the view, and then the data is the SQLite file that we had to create, and those can be hosted on like a storage bucket or in GitHub. Like these are all very small. So we went from something that cost $30 a month to, I don't know, like whatever storage bucket is. Like GitHub's free. You could host this for free. It's public data. And if all you're trying to do is show information, like you don't really care about, um, you don't really care about persistence. So like as soon as you refresh this page, this session is gone. If you don't care about that, then this is fantastic. And I think those are the two things that kind of like just not blew my mind, but I'm just kind of just staggered by is how well GPT was able to go from a Dash app, basically a Python app, to leveraging a bunch of JavaScript libraries and creating a static page using those libraries. Like with very little prompting, it got me to about 85% of the way. It didn't know the name of the tables inside the SQLite, so I had to like kind of coach it a little bit in terms of like updating its queries. But yeah, it got it most of the way there. And now, like all that GitHacks does is if you upload an HTML file onto GitHub, it doesn't. If you open that file up, it doesn't display it as a HTML. Like it has the wrong header for the browser to pick it up. But if you go to GitHacks, feed it your HTML file, it'll correct the web server so that it knows to show the HTML versus just showing you the rendering or the HTML code. Yeah, that's it in a nutshell. I thought that was pretty cool. It's just we went from $30 to like free.